In other videos, we've already covered general properties of triangles. In this video, I want to cover properties of special triangles. Special triangles may not necessarily be tested directly on the ACT, although sometimes they are. The real value in special triangles actually comes from the fact that if you can recognize a special triangle and know its properties, it's going to save you valuable time answering certain geometry questions. An equilateral triangle has all sides the same length and all angles at 60 degrees. So if you're given a triangle with two angles measuring 60 degrees, you should know that the third angle is going to be 60 degrees and that all the sides are going to be the same length. Likewise, if you're given a triangle and all three sides are given the same length, then you should know that all three angles are going to be 60 degrees. An isosceles triangle has two sides the same length and two angles the same measure. So if you're given a triangle that has two angles of the same measure, you should know that their opposite sides are going to be the same length. Likewise, if you're given a triangle with two sides the same length, you should know that their opposite angles are going to be the same measure. In a 45-45-90 triangle, or an isosceles right triangle, the hypotenuse will be the length of one of the other sides times the square root of 2. If you're given the hypotenuse, the length of either of the other sides is the length of the hypotenuse divided by the square root of 2. If you have a triangle with angles measuring 30 degrees, 60 degrees, and 90 degrees, the hypotenuse will be twice the length of the shortest side, and the side opposite the 60-degree angle will be the square root of 3 times the shortest side. If you have a triangle with side lengths in the ratio of 5 to 12 to 13, or of 3 to 4 to 5, then you have a right triangle. Those are actually known as Pythagorean triples.